Okay, this is a demonstration of the code I've got running on the new Waveshare reflective LCD. This has been coded in Arduino IDF. A few elements going on here. We obviously have the main dashboard page. This is showing you all of the parameters that come natively off the device. We have temperature and humidity, obviously. It's a big feature of this board. It has the onboard sensors. Real-time clock displaying date and location and time zone. These have been obtained obviously through NTP, but then running off the real-time clock. The unit is now connected to Wi-Fi, and we can see that signal strength in the top left-hand corner, time zone, and then of course the internal battery. This particular unit's got the battery. So this is the first of a number of different pages. You can see here on page 2, we have a replication of much of what was on the first page. We have the location and the time zone, the real-time clock displayed on analog this time, the date in the bottom left, and in the bottom right we have the onboard sensors. We have the temperature, relative humidity, and the battery voltage. From the real-time clock, we've been able to set up a couple more, 6 independent time zones, 5 for Australia during daylight saving time, and UTC. This is now utilizing the weather from an API. We have the current conditions for Sydney. Current conditions, we have a 2-line blurb, feels like, high and low, UV, and humidity. None of this is coming off the device. It's not being indexed locally. It's all coming down from the API. We have weather, outdoor temp, air quality, parts per million, weather last updated. Now, the navigation is pretty straightforward on this. We're just a single key press to cycle through the pages, and it's just a loop. But the alternate key is an update. So if we press that, we'll initiate a weather grab, and we'll see the last updated go down to 0 minutes. Moving through, we have an hourly forecast. Once again, all coming off the weather API. Next weather page is a 3-day outlook, including today. So we have the 38th, then the 9th, and the 10th. Next few pages are a little different. We start moving into some astronomy. Next page is a bit of a general overview, all text-based, apart from the moon graphic. So we have sunrise, sunset, day length, and the solar noon. Then we move down into the moon phases. Next few pages graphically represent this similar information. So we have the lunar orbit with the illumination, the overall age date of the lunar cycle, the various elements of the lunar cycle and where we are in the progression. And we are 3 days away from the last quarter. The date range to the next event will move as we progress throughout the lunar cycle. And we have the daytime progression, east to west, for the sun arc, marking solar noon, and then we have our day length, our solar noon, and hours to sunset. Our sunrise and sunset are marked on the bottom of the solar arc. Continuing the astronomical theme, we move now into the seasons. And we've got 2 pages here that are very much the same. This is one format with the seasons in the 4 quadrants and the elliptical showing the different equinoxes and solstices, 12 days away from our March equinox. Next page, as I said, is very much the same, just a slightly different format, showing you the days to the next event. We have an animated marker this time as well for the position of the Earth in its elliptical. Obviously, this is configured for the Southern Hemisphere. Days to in the 4 quadrants show you the days to the relative events in those quadrants. So the bottom right shows we are 12 days away from the autumn equinox, which for us in the Southern Hemisphere is in March. And then we have 104 days to the winter solstice in June, and so on around we go. Now we go back to some internal temperature sensors. This is an internal trending for the internal sensor. You can see the trend graph over the last 6 hours, max and mins, and a statement about the actual trend itself. Same for the relative humidity. The final page shows us some local sensor information. And then back to the beginning. So nice little gateway project, coded in Arduino. Maybe not the most efficient way to code something like this, but it does generate a great result and a bit of a gateway coding project. Next project we're moving on to will be the M5 stack tab 5. We won't be coding that in Arduino though. We are going to code that through an SPF IDF platform. I'll share some code, I'll share a link, and by all means, enjoy.